A large candy company has a product that comes in several different colors. The company claims that 31.6% of the candies are colored red. For a sample of size 600, what is the standard deviation for the distribution of sample proportion of red candies? In a random sample of 600 candies, what is the probability that less than 30.2% are red? And then what is the probability that a random sample of 600 candies results in higher than 34.5% red candies? So to answer the three first parts of the question, we notice that the sample size is big. So you can assume that the distribution of sample proportion is going to be normal. And we know that because n times p times 1 minus p greater than or equal to 10. So if you compute that here, this is equal to n times p times 1 minus p. If the condition meets the criteria, which is greater than or equal to 10, then we can produce a normal distribution out of the distribution of sample proportions, and we can treat it as a normal distribution. So n is equal to 600 times p, which is 0.316 times 1 minus p, 1 minus 0.316. The answer is greater than 10. That means we can produce the normal distribution using the distribution of sample proportion, and we can treat it as such. And that means we're going to compute the mean of the distribution, which is equivalent to the population proportion, 31.6 or 0.316. And the standard deviation is equal to the square root of p times 1 minus p divided by n, which is, I'm going to compute right here. So it's equal to square root of 0.316 times 1 minus 0.316 divided by 600. And the answer is this one. This is going to give me the standard deviation. Now I can answer the first question. In a random sample of 600 candies, what is the probability? So the question is asking about the probability. That means I need to find the area under the curve, and I'm going to use the norm distribution function. That less than 30.2%, so it's giving me a proportion. This is a proportion, so it's not actually the area under the curve. This is the proportion because I created the distribution of sample proportions, and the numbers at the bottom of the curve are proportions, and this is one of them. So I know that the mean is 0.316. 30.2 is approximately here. I can write it like this. Less than means the area under that. So to find that area, I'm going to use norm dot distribution of 0.32, comma the mean 0.316, comma the standard deviation we computed, which is this value right here, comma true, to find the answer. So I'm just going to compute the value right here, norm dot distribution of 0.302, comma the mean 0.316, comma the standard deviation, which is we computed in the previous step, comma true. So I'm just going to copy that and paste it into here. And we determined that the standard deviation, we computed it in the previous step, so I'm just going to copy that and paste it here. And that is the first and second part. The third part is asking what is the probability again. So it is still asking about the probability or the area under the curve. Again, this number is not the area under the curve. It's a proportion because we are dealing with the distribution of sample proportions. So to find that area that is higher than 34.5, this is similar to saying, okay, this is the mean 0.316. 34.5 is approximately here, 0.345. And we want anything higher than that. So the probability that a number that is higher or a proportion that is higher than that. So to find that, we're going to use 1 minus norm distribution. Dot distribution of the number 0.345 345, comma 0.316, the mean, comma the standard deviation, comma true. And then I'm going to compute this number right here. 1 minus norm dot distribution of 0.345, comma 0.316, comma the standard deviation that we computed, comma true. So that is the answer. I'm just going to copy that and paste it into my answer box. The last part, there is something that has changed, which is the sample size. Notice how the sample size reduced dramatically. What is the probability that a random sample of 12 candies result in 4 candies or fewer? First of all, 4 is a number, is not a proportion. Second of all, I have 12 candies. Let's test if the sample size of 12 is going to produce a normal distribution or not. And that is the key. If it doesn't meet the first condition, then we have to use the binomial distribution. If it meets the first condition, then we can continue using the normal distribution of the distribution of sample proportions. So I'm going to use this condition right here. So I'm going to compute it here, equals 12, the sample size, times the probability, 0.316, times, open parentheses, 1 minus 0.316. And the answer is less, way less than even 5. And that indicates that this sample size is actually too small, and I can't produce a normal distribution using the sample size. If it was above 5, it has a chance, but it's less than 5. So I have to resort to the binomial distribution in order to answer that last question. And as a result, I need an n. N is 12 in this case, and the probability of success is given at the beginning of the question. So all I need to do is I'm going to build a table based on these two numbers. We remember how to do that, hopefully, 0, 1, 2, 3. Okay, and I'm going to click and populate as if I'm populating until I get 12 of them, and then binom dot distribution of the number, comma the number of trials is 12 actually, comma the probability of success is 0.316, which is given, comma false for the binomial distribution. So it turns from a continuous distribution to a discrete distribution. And the question says, what is the probability that a random sample of 12 candies result in 4 candies or fewer? 4 or fewer, that means we're going to add up all of the probabilities of 4, 3, 2, 1, 0 together, and that will give me this number. Now I'm going to use this number and paste it right here, and it's the right answer. So as you see here, we have to check for the condition of normal distribution, and I would say if it gives you a number at least of 5, we can still use the normal distribution of the distribution of sample proportion. Or if it's less than 5, we can't do that, and we have to resort to the binomial distribution to solve the question. I hope this video helped you, and I will see you in a different one.